Hey again, everyone. Today we're thinking about bivariate analysis, which is the next step in your quantitative analysis process. In bivariate analysis, we're interested in exploring for the very first time the relationships between variables. I know that as you continue to construct your data sets after following some of the instructions in Module 3, you're going to start to look through these columns and get a feel for the way that these variables trend together. And in fact, I've already done that in some of the previous videos, just kind of looking across columns with data sets and making some assumptions about where the high values are, where the low values are, and how those relate to the different cases that we're exploring in the data. However, to conduct bivariate analysis in a more rigorous way, we want to make sure that we have tools, both visual and statistical, that will allow us to evaluate whether or not there is any relationship between our independent variables and our dependent variables, not to mention other forms of relationships in our data space as well, including relationships between some of those lurking variables that we've included that we are now referring to collectively as control variables or third variables. So both IV and DV relationships are things that we want to consider in this bivariate analysis stage, but also some of those potential lurking or spurious correlations between other variables and the IV and the DV. So to understand bivariate analysis, the thing that we need to do more than anything else is remember what level of measurement our variables are taking. So nominal variables, things that have essentially categorical codings, things like saying that you're in college or not in college, or you have a certain level of education, essentially binary classifications of different things. A racial breakdown would be nominal, right? These are things that are simply names. We don't have a clear order in our minds here. Ordinal variables, which again are variables that don't have scales, but are nevertheless things that we can arrange from higher to lower. So things like economic evaluations, where people say the economy is great, or it's middling, or it's bad. Those things have an order, but we don't really understand how much distance there is theoretically between those different levels. And then continuous variables, where we do have some sort of scale. Things like age, which can be measured in years, height, which can be measured in feet, or in meters, or inches, or whatever. GDP, which can be measured in dollars. And so all these different kinds of levels of measurement necessitate different kinds of bivariate analyses. In the second video in this module, I'm going to show you how to use some R code to engage in visual examinations of these relationships. I'm sure many of you are familiar with some of these tools already, things like scatter plots, things like histograms, things that will allow us to evaluate relationships. However, a lot of those visual tools are only appropriate to very specific relationships. And we'll see a handy guide in just a moment that will be helpful for that, for making those determinations. So the first types of relationships that I want to consider are nominal relationships. So this is really the bivariate association between two variables that have essentially categorical codings. So one example we could think about would be the relationship between people who are or are not college educated and some of the industry classifications that we could give them. So we could say, somebody who's working in heavy industry versus someone who's working in the service sector versus someone who's working in some sort of professional capacity. We could imagine constructing some kind of visualization that would give us a way to assess the relationship from an early sort of descriptive way. So my preference for this is what's called a grouped frequency histogram. And if we go over to, I'll tab over to this website. I'll be posting this in the comments to the video, so you'll be able to see it. This is essentially this master list of all kinds of different visualizations that you can create using a couple of lines of code in RStudio. I'll be, of course, providing an R file here with some examples as well. But this is one example of such graphic in which we've got essentially a histogram which counts the number of observations in a data set and looks at, in this case, the class of car, so whether it's a two-seater, a compact, midsize, etc., and the auto manufacturer, using a very familiar data set called MT Cars, which is available as just an example data set in RStudio. And so you can see that the colors here really show you the distribution. So in this case, like Audi makes a lot of compact cars, whereas Dodge, as we might imagine, makes a lot of pickups. And so again, this just gives us a way to evaluate the data space fairly effectively without having to go through a lot of trouble. So that's the first one, nominal relationships. I prefer this kind of group frequency histogram. And again, in the second video, you'll see some R tutorials on how to create exactly such a histogram using your own tools. When we think about nominal or ordinal relationships, essentially relationships between variables that again have just some sort of basic categorization, and these other variables that have some inherent sense of order but do not have a scale, we could also do these exact same kinds of graphics. So you could imagine, again, with an ordinal variable here, if this were not class, but rather, let's say the some sort of ranked size of vehicle, or sort of vehicle I don't know, some way that we could rank these things in order from sort of smallest car, or sort of most minimalist car, to most extensive car. So you could imagine an ordinal scale going from like most efficiency to most luxury or something. If this were some sort of ranked scale, it really doesn't change much the way that this visualization actually works. In this case, we still get a sense of sort of where the data are in the data space and how many of each belong to each manufacturer. Now let's contend with relationships between nominal variables, again, those same categorical variables, and continuous variables. So in this case, we've actually brought in a type of variable in which we've got some sense of scale. So something, again, like age, like some of the variables you might be contending with, including GDP, other continuous measures that come from indices. So like the press freedom index is also a continuous variable that has this extensive scaling, right? If we want to do this, there's actually a lot of ways that we could do this. And my preference really is to either, you do some kind of group density plot, which we'll see some examples of later, but really the go-to for me is a box plot. And so if we go over to this is another example from that rstatistics.co website. Here's a box plot that's again looking at this data on cars. But for this visualization, they're including a continuous variable, which is the miles per gallon in the city of each car. So we've got all these cars in here, and they've created this data set or this analysis that uses a box plot to show essentially where are the median, right? The median city mileage, where's the sort of interquartile range here, or sort of where's the top 75th percentile and bottom 25th percentile of the cars in each group, and where are the extreme sort of outliers at the top and bottom of the distributions. That's essentially what a box plot is. But we're able to really look at those thick lines and then the boxes really to compare, in general, sort of the overall pattern across these different types of cars. And so we can see that this graphic really kind of shows us something that we probably would have already known, right? Compact cars and mid-sized cars and subcompact cars especially tend to get better miles per gallon, so they're more fuel efficient than cars like, I'm not sure what's going on with these two-seater cars. It might be that they burn a lot of fuel because they're like fast, roadster cars. But minivans tend to have lower miles per gallon. SUVs tend to do really poorly in this, and pickups, of course, because they're also very powerful engines, tend to have much lower miles per gallon. So again, this is another way that we've got a categorical variable in the x-axis here, but we've also got now, for the first time, a continuous variable. So you can see how a box plot is very different than, say, this kind of plot, where this is the count of these different kinds, and the colors are what are showing us the relationship between the two variables. In this case, we actually have a variable in the y-axis instead of just the count, and the categories are arrayed across here for the first time. So in this case, the box plot, the y-axis actually has a statistic. It actually has a variable here. Whereas in the previous one, the two variables are really in the colors and in the x-axis. So the count is not a real variable, it's just simply the number of each type of manufactured car that we have in the data set. So these are, again, very different visualizations. And you'll see that if you tried to do this with this type of data, if you tried to put city mileage into your histogram, it would break. It would not work. It would give us an extremely messy and problematic kind of visualization. So be very careful about diagnosing which of these different types of variables are in your data set. That's all for now. I'll see you on the other side. We'll look at some R code.